Well, we've had some good work done, and we're getting close to many things. So, I finished up the JSON serialization deserialization thing, figured out how to do it. So we kept the step and we made two serializable step, and that way we just serialized the serializable step. And each, let me just pull this up. So each step is required to create a new serializable step, and they essentially put the parameters, they build their own parameters objects. That way they can put in whatever they need. And then to get it out, we essentially deserialize whatever the element is for the step to a serializable step. And then we switch on the name, and then based on the name, we return a new particular subtype, like as step, and then each of the steps can be initialized using this parameters. Oops, let's go back to as step. So as step, here it is. So it has a constructor that takes in the map, parameter map. And it does things like, okay, make sure it's not null, and make sure it contains marker, and make sure that marker is a string. If it's a string, go ahead and cast it. Otherwise, we have a problem. The logic's fairly simple. So that allows us in one little area to take care of serializing, deserializing, and separate out the serialized format from the actual implementation details, which is very, very nice. The only weird thing you have to do is you have to register this using a register type hierarchy adapter, because it will JSON will automatically try to serialize based on the actual subclass type, the concrete class, rather than the interface. What this does is say, okay, for the interface and anything that extends this interface, use this type adapter and use these serializers and deserializers. So that was good. And then, I think it was 2 or 3 days ago, whenever, we had traversal working. Been doing more work on traversal, not completely done, but we implemented query. So we can query, we can say here is a batch of traversals, execute these traversals, and any new traversals that come up also execute those if they are in this graph, and then return all of the new stuff you added out of this. So, which I may change. Not sure yet, because this piece is a whole bunch of extra memory we may not need to use. But let's go ahead and let me run. Yeah, I still have it set. Do I have Sublime up? I do. Okay, so that ran and gave us query. And if you'll notice, all we did is JSON to JSON the actual query. So what we did is we just started at a start ID, jumped 2 nodes, and then just stored the type as payload key. So let me get this to where you can see it nicely. There we go. So our, here's our, one of these was our first traversal. I think, actually you can't actually tell. But you have a traversal F338, node, 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 and then there's payload key. So it took leaf 2. So what this actually does is it goes from start to a branch, and then it branches, and there's 3 edges from branch to leaf 1, leaf 2, and leaf 3, which is right here. So this one went to leaf 2. Here's the list of steps it completed. 15B1 went to leaf 3 and completed. And then 7065 went to leaf 1 and completed. And they all came back and they were all happy. Oh, it's so beautiful. So it worked. It worked and did exactly what it was supposed to do, which is so nice. So we also started working on the REST endpoint. So you essentially get a query, execute the query, return the query. Still need to worry about errors and some other stuff like that. But it should be relatively simple. And this right here, between this and query, we can actually execute a query locally, get back all of the unfinished ones, loop through them and figure out which, what is it called? Which repositories they need to go into, essentially separate them out and create new queries with those traversals in them. Send those queries to that particular repository's query endpoint and get back a list of, all of the queries plus any new queries, continuing on until you're finished. And we can do that in parallel. So we can do a breadth first progression there. And it'll loop, and it'll branch, and it'll backtrack, and everything will work exactly the way it needs to work. And we just let these things loose, and they all go, and they come back. And we collect them back up, and we can collect them back up really easily by merging these maps. By merging these maps, because every traversal has a UUID that's associated with it that's consistent and doesn't change. So if you have a traversal that goes out and it hits a branch, one of those branches will have the original number, and then there'll be two new ones. That way you can take that, merge it back in, and stamp over. So anything you get back, you can immediately stamp back over whatever you sent out and have a fully updated set of traversals within that query that you look at for completion. So let's see. Don't save. So I think that's kind of it for today. I've been working a lot on testing. Who cares? You don't really care about testing. But a lot of, come on, just for crying out loud, no breakpoint. I can't grab it. There it is. So you'll notice that we have a lot of 100% and a lot of 0%. Path element is really close. So we're gonna bulk up the testing, get that good and solid. Finish out some of the queries, the query testing, make sure everything executes correctly, making sure that traversals are giving back and putting themselves in a state that's correct, and that gets back out to the query and gets returned correctly. So everything's going pretty well, just chugging through, and hopefully we can actually build the family traversal query and then execute it and see what happens. Oh, it's gonna be so beautiful, so wonderful. So yeah, I'm a little excited. Take care. Have a great day.